Just now we found that 243 is not a perfect cube. And we wrote 243 as the product of its prime factors as 3 into 3 into 3 into 3 into 3, right? And there is only one triplet. Therefore, 243 is not a perfect cube. Now, what should be multiplied by to the number 243 to make it a perfect square? If there is one more 3 here, if there is one more 3, then we could have written this as a triplet again. If you multiply this by 3, this number should be multiplied by 3 because there is an equality. If A is equal to B, then 2A is equal to 2B. Multiplying both sides by the same number will not change the equality. To make this a triplet, we have to multiply this number by 3 so that we have triplets of 3. To make it equal, we have to multiply this by 3 also. We get 243 into 3 as 3 3s are 9, 3 4s are 12, carry 1, 3 2s are 6 plus 1, 7. 729 is the smallest multiple of 243. 243 is the given number and 729 is the smallest multiple of 243. Why it is a multiple? Because it is multiplied by 3. It is the smallest one which is a perfect cube. Let us study. Now let us study the next topic, smallest multiple that is a perfect cube. In the textbook they have given an example. Raj made a cuboid of plasticine. Length, breadth and height of the cuboid are 15 centimeters, 30 centimeters, 15 centimeters respectively. Anu asks how many such cuboids will she need to make a perfect cube. Can you tell? Raj said volume of a cuboid is L into B into H, that is 15 into 30 into 15. By writing the prime factors of this product, it is 2 into 3 into 3 into 3 into 5 into 5 into 5. Since there is only 1 2 in the prime factorization, so we need 2 into 2, that is 4, to make it a perfect cube. Therefore, we need 4 such cuboids to make a cube. Did you understand here? Here, if you multiply the right hand side by 4 and left hand side by 4, you will get the perfect cube. Such 4 cuboids are required to make it a cube. Now, you can understand it by solving another example. Is 392 a perfect cube? If not, find the smallest natural number by which 392 must be multiplied so that the product is a perfect cube. Solution: 392 is equal to 2 into 2 into 2 into 7 into 7. How did they get it? By continuous division. Do it on your paper, on your book. Definitely you will find it. The prime factor 7 does not appear in a group of 3. Therefore, 392 is not a perfect cube. To make it a cube, we need one more 7. In that case, 392 into 7 is equal to 2 into 2 into 2 into 7 into 7 into 7. This is equal to 2744, which is a perfect cube. So, did you get the prime factors of 392? How should we do? 392. Divide it by 2 first. 2 ones are 2, 1 remaining, 2 9s are 18, 1 is remaining, 2 6 are. Then 2 9s are 18, 2 8s are 16. Then 2. 2 4s are 8. 2 9s are 18. Then 7. 7 7s are 49. 7 1s are 7. This is how 392 is written as the product of these prime factors. Hence, the smallest natural number by which 392 should be multiplied to make it perfect cube is 7. Now, example 3. Do it on your own without looking into the book. Self-practice increases your confidence. Try first. If you don't get it, the answer is here. By continuous division, you can find the prime factors of this number like this. The prime factor 5 does not appear in a group of 3. So, this number is not a perfect cube. In the factorization, 5 appears only one time. If we divide the number by 5, then the prime factorization of the quotient will not contain 5. Here, the reverse process. Division is the reverse of multiplication. So, if we divide the given number by 5, we get the number which is a perfect cube. Why? Because that number is written as the product of prime factors which can be grouped in 3. They could be written as the triplets, product of triplets. Then it is a perfect square. What is that number? If you divide left hand side by 5, right hand side by 5, you will get 10,648 in the left hand side and 5 is not there in the right hand side, and right hand side is the pure product of triplets, so that it is the perfect cube. Now the next example. Is 1188 a perfect cube? If not, by which smallest natural number should 1188 be divided so that the quotient is a perfect cube? By finding the prime factors of 1188, we could write the product like this. The primes 2 and 11 do not appear in groups of 3. So, 1188 is not a perfect cube. In the factorization of 1188, the prime 2 appears only 2 times and the prime 11 appears once. So, if we divide this number by 2, 2, 11, product of 2, 2 and 11, that is 44. Then the prime factorization of the quotient will not contain 2 and 11. Hence, the smallest natural number by which this number should be divided to make it a perfect cube is 44. Did you get it? I'll explain once again. 1188 is equal to find the factors. 2 5s are 10, 2 9s are, 2 4s are, 2 2s are 4, 2 9s are 18, 2 7s are. Then 3 9s are 27, 2 is remaining, 3 9s are. Then 3 3s are 9, 3 3s are 9. Then 3 1s are, 3 1s are. Then 11. So we could get only one triplet and 2 is appearing only twice, 11 is appearing only once. Therefore, if you divide 1188 by 2 into 2 into 11, you are remaining with 3 into 3 into 3, which is a triplet and can be written as the cube of 3. And this number is 1188 divided by 44 gives you 27. Got it? Now, example 5. Is 68,600 a perfect cube? If not, find the smallest number by which this number must be multiplied to get a perfect cube. See, when you are asked to find the number by which the number should be multiplied, then you should multiply the number also and the factors also. Whereas in the division process, you have to divide by that number. You have to find that number by which, by dividing, you get the perfect cube. Here, by multiplying, you get the perfect cube. 68,600 is written as triplets of 2, 7. But 5 is appearing only twice. Therefore, if you multiply this product by 5, you will get the perfect cube. That means you will be getting the triplets. That is triplet of 2, triplet of 5 and triplet of 7. If you multiply the right hand side by 5, you have to multiply the left hand side by 5 also to maintain the equality. And the number which you get will be a perfect square. Therefore, 5 is the smallest number to be multiplied to make this as a perfect cube. Got it? Now, let's understand more by practicing some more numbers. What about 2700? By observing it only, we can say no, because there are only 2 zeros. 2700 is equal to, is not a perfect cube. Why? 2700 is equal to 27 into 100. 27 is 3 cube into 10 into 10. This is not a perfect cube. And in a perfect cube, there are always 3 zeros. If it would have been 27,000, then it is a perfect square. Perfect cube is equal to 30 cube. This is how you should find the smallest number also and check whether the given number is a perfect cube or not. What about the next number? 16,000. Here, 16,000. Even though there are 3 zeros, 16 is not a perfect cube. If you multiply this by 4, then 16 fours are 64 into 1000. Got it? No. Confused? 4 into 16 is 64 and 3 zeros just write in front of 64. Multiplying the non-zero digits, you get 64 and just write 3 zeros in front of that number. You will get the product. And 64,000 is 64 into 1000. We know that 64 is 4 cube and 10 cube. This is 40 cube. This is how you should get the answer. 16,000 is not a perfect cube. What about 64,000? Yes, just now I explained it is a perfect cube. What about 900? 900 is not a perfect cube. Why? There are only 2 zeros and 9 is also not a perfect cube. What about 125,000? 125,000 is equal to 125 into 1000. We know that 125 is 5 cube and 1000 is 10 cube. It is 50 cube. It is a perfect square. Just by looking at the number, you should be able to say whether it is a perfect cube or no. And 36,000? No, 36 is not a perfect cube. Even though it is having 3 zeros, it is not a perfect cube. What about 21,600? It is also not a perfect cube. Even though 216 is a perfect cube, there are no 3 zeros. There should be 3 zeros in front of a perfect cube, then it is a perfect cube. If it is 216, 3 zeros. 216 is a perfect cube. Then it is 216 is a cube of 6, right? 6 6 are 36 into 6. 6 36, 3 carry, 6 3s are 18 plus 3, 21. Yes, 216 is a perfect cube. It is 6 cube into 10 cube. It is 60 cube. Got it? This is how you should understand to find the cubes. What about 10,000? It is also not a cube. Here 27, 1, 2, 3 zeros, 1, 2, 3 zeros. It is a perfect cube. Why? (27) 1, 2, 3, 1, 2, 3. This is written as 27 into 1000 into 1000. Am I right? By multiplying the non-zero digits, 27 into 1, you get 27, and there are 3 zeros. 3 zeros here, 3 zeros here. We should add as many zeros as they are in the multiplier or the multiplier. Here multiplier is having 3 number of zeros and 3 number of zeros. We should write 6 number of zeros in front of 27. And 27 is cube of 3. And 1000 is cube of 10. Therefore, this number is equal to 3 cube into 10 cube into 10 cube. That is 3000. Am I wrong? Sorry, 300 cube. Correct? Okay. Then what about 1000? It's a perfect cube. What pattern do you observe in these perfect cubes? These perfect cubes are the multiples of 10. Now let us start exercise 7.1. Which of the following numbers are not perfect cubes? For that we have to find the prime factorization. Can you do it, children? Do it on your own. How did you do it? By continuous division. See, I have done it for you. 243 by continuous division. We could find the factors and written like this. Did you get it? 243. Here the prime number 3 is appearing only twice. If you multiply the number by 3, we can write 243 as this, and 729 is a perfect cube. But they have not asked you to find the smallest number. Just you say whether 216 is a perfect cube or not. Here this is 243. Oh, second main. So here I have done the second main. The first main I will do for you. Oh, it's here. See. $216. This is the continuous division. Just check whether You also got the same prime factorization. It is a perfect square cube. Here this is not a perfect cube because 2 is appearing only once. 128 is not a perfect cube, and the third one 1000 is yes, and fourth 100 no. And what about fifth one? 446,656 by continuous division like this. I will do it for you again. Are you getting it? Or shall I explain? Here 2 2s are 4, 2 3s are 6, 2 3s are 6, 2 2s are 4, 1 is remaining, 2 8s are 16. 2 1s are 2, 2 1s are 2, and 1 is remaining, 2 6 are 12, 1 is remaining, 2 6 are 12, and 2 4s are 8. Again by 2. Taking first 2 digits, 2 5s are 10, 1 is remaining, 2 8s are 16, and bringing down 6, 2 3s are 6, 2 2s are 4. Again by 2. First digit, 2 2s are 4, 1 is remaining, 2 9s are 18. Then bring down 3, 2 1s are 2, 1 is remaining, 2 6 are 12. Then 2, 2 1s are 2, 9 divide 9 by 2, 2 4s are 8, 1 is remaining, 2 5s are 10, and 1 is remaining, it becomes 16, 2 8s are 16. 2 7s are 14, then 5 divide 5 by 2, 2 2s are 4, 1 is remaining, 2 9s are 18. Are you getting it? If you don't understand, you can divide separately and get it, but it's a waste of time because you have learnt it in your earlier classes. You have to give importance to the time also. You are in 8th standard now. Practice, practice, practice. Practice makes man perfect. You please practice all these sums again and again. Repeatedly you do these sums so that it will be saved in your subconscious mind, and in the exam you are able to write quickly without wasting time. Here you should divide this by 3. Taking 7, 3 2s are 6, 1 is remaining, 3 4s are 12, and 3 3s are 9. Again by 3. 3 8s are 24, 3 1s are 3. Then by 3 again. 3 2s are 6, 2 is remaining, 3 7s are 21. Then 3 9s are 27, 3 3s are 9, 3 1s are 3. Here we are getting triplets of these numbers. Therefore, 466 56 is equal to 2 cube into 2 cube into 3 cube into 3 cube. So this is a perfect square. The last one of the first main. Got it? Now the second main. Find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. For 243, how do you do it? By continuous division, you have to find the prime factors of the given number. Second main. First one, 243. To find the prime factors, we have to divide the given number continuously. Since this is the number with 3 in its ones place. So we can divide it by 3. Taking 2 digits at a time, 24. If you divide 24 by 3, 3 8s are 24. And bring down 3, 3 1s are 3. Again by 3, 3 2s are 6. 2 is remaining. It becomes 21. 3 7s are 21. Here you should be fast in telling the tables and finding the factors and subtracting. Like 81 divided by 3, 3 2s are 6, 8 minus 6 is 2, bring down 1, 3 7s are 21, then 21 minus 21 is 0. This is how we have learned to divide the number by any other number. You have learnt it in your earlier classes, so this time you have to do it in your mind. By practice, it will be very easy for you children. Don't be confused. Just visualize this division which you have learnt in your earlier classes in your mind, so that it will be easy for you to find the quotient. Again by 3. 3 9s are 27. Then 3 3s are 9. Then 3 1s are. Here we could group only one triplet. If there is one more 3 here, we could have done it another triplet. Therefore, 243 into 3 is equal to 3 into 3 into 3 into 3 into 3 into 3. This 3 is multiplied on both sides of the equation. As we know that 243 is equal to 3 into 3 into 3 into 3 into 3. We have found the prime factors of 243 like this. If you multiply the number by 3 and these prime factors by 3, we are maintaining the equality. There is an equality. By multiplying this, we are making this number a perfect cube. 243 into 3. 3 3s are 9. 3 4s are 12. 1 carry. 3 2s are 6 plus 1. 7. 729 is a perfect cube. So, 3 is the smallest number which should be multiplied to the given number to make it a perfect cube. What about 256? Second one. 256. By continuous division, we get 256 as product of triplets of 2 and 2 and 2. To make 256 as the smallest multiple, that is a perfect cube, multiply 256 by 2 so that the multiple or the product becomes a perfect cube. That is 256 into 2 is equal to 2 into 2 into 2, 2 into 2 into 2, then 2 into 2 into 2. So this is the smallest number. We are going to multiply. So that this is 256 into 2 is 512. Is a perfect cube. Correct? 2 is the required smallest natural number by which 256 must be multiplied so that the product is a perfect cube. No, 512 is a perfect cube. This is equal to 512 is equal to 2 cube into 2 cube into 2 cube. It is 2 into 2 into 2 bracket cube. It is 8 cube. Okay. And 512. 512 is the smallest multiple, that is a perfect cube after 256. Similarly, 72 is done for you. By continuous division, we are able to write 72 as the product of its prime factors like this. And if you multiply both sides by 3, you will make a perfect cube. The prime factor 3 does not appear in a group of triplets or 3. Therefore, we need to multiply 72 by 3 to make it a perfect cube. Then the next question. 675. By continuous division, we are able to write the prime factors of 675 like this. 675 into 5 will make it a perfect cube. This 5 is the smallest natural number by which (675) must be multiplied so that the product is a perfect cube. And the fifth one, 100 is 10 into 10. That gives you only 2 prime factors. To make it a perfect square, we have to multiply by 10. So that the product is a perfect cube. It is 10 cube. Correct? Now the third main. Find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. The first one, 81 is given, and by continuous division, we found the prime factors as 3 into 3 into 3 into 3. Here, one triplet of 3 is there. This 3 is not required. Therefore, if you divide this number by 3, you will get the perfect cube. Got it? This is the reverse process of multiplication. Here, the prime factor 3 does not appear in a group of triplets or 3. So, 81 is not a perfect cube. In the factorization, 3 appears only one time. If we divide 81 by 3, then prime factorization will not contain 3. So, 81 divided by 3 is equal to 3 into 3 into 3 is equal to 27 is a perfect cube. Therefore, the smallest number by which 81 should be divided to make it a perfect cube is 3. Then 128. I have done this for you people. You do it on your own. If you don't get it, you can look into the video to get the perfect answer. Got it? Now the next one. Here, third one. Third one is 135. By finding the prime factors, we are able to write 135 as 135 is equal to 3 into 3 into 3 into 5. This 5 is appearing only once. So, if we could remove that 5 by dividing both sides by 5, we get the quotient as a perfect cube. Now the fourth one, 192. By continuous division, we could find the prime factors as 2, 2, 2, 1 triplet, 2, 2, 2, 2 another triplet and 3 is remaining. If you divide the given number by 3, you will get the perfect cube. And what about the fifth one? I am a little confused one. I want to save paper. So I do like this. Hope you can see it properly and understand it. This is the fourth one. Fourth one is complete. 64 is equal to 4 cube and 3 is the natural number by which we should divide the given number so that the quotient is a perfect cube. But in examination, you should not do like this. It should be very clear. Like I showed you here. See, in your answer sheet, your continuous division should be very clear and the writing is also perfect. Here, how I have explained, for the first question, this should be the answer for this question when you are asked to write in your examination. Can you write like this for these two sums also? Try, or else I'll give you in the next video. Now the fourth one. Cuboid of plasticine of sides 5 cm, 2 cm, 5 cm. What is the fourth question? Parikshit makes a cuboid of plasticine of sides 5 cm, 2 cm, 5 cm. How many such cuboids will he need to form a cube? Cuboid of plasticine of sides 5 cm, 2 cm and 5 cm. That cuboid is 5 into 2 into 5 is 1 cuboid. We need 2 more cuboids like this so that we can make as a triplet. 5 into 2 into 5, 5 into 2 into 5, 5 into 2 into 5. We need such 2 triplets to make it a perfect cube. So he needs 2 more cuboids. This is 1 cuboid and this is another cuboid. This is another cuboid. He needs 2 more cuboids to form a cube.